Welcome to Study Loop.
Okay, so for part A, we have when there is less than 30 megabytes free on the hard disk, a warning message is sent to all users. Okay, so let's let P of X be that X has less than 30 megabytes free. And let's let Q of X be warning message is sent. Let's actually make this Y, sent to Y. Okay, so we have that when there's less than 30 megabytes free on the hard disk, a warning message is sent to all users. So there exists some X such that when P of X or X is less than 30, then this implies that all users get a warning message for all Y, Q of Y happens. Okay, now for part B, no directories in the file system can be opened and no files can be closed when system errors have been detected. So let's let R of X be that directory X cannot be opened. And let's let S of Y be file Y can be closed. Okay. No directories in the file system can be opened. And no files can be closed when the system errors have been detected. Okay, so let's see, we actually need one more. We need when, let's let T of Z be the system error Z can be detected. Okay, then when a system error has been detected, so for all Z, T of Z, this implies that for all X, the negation of R of X holds, and for all Y, the negation of S of Y holds. Now we have the file system cannot be backed up if there is a user currently logged in. So let's let U of XY be that user X is logged into Y. And let's let V of Y be the file system Y can be backed up. Okay, so the file system cannot be backed up if there is a user currently logged in. So there exists some X and some Y such that when a user is logged into Y, then this implies that we cannot back up that system. So V cannot back up. Now for part D, video on demand can be delivered when there are at least 8 megabytes of memory available and the connection is at least 56 kilobits per second. Now let's let W of X be a computer X contains at least 8 megabytes of memory. Let's let A of X be computer X has connection speed of at least 56 kilobits per second, and let's let B of X be a video on demand can be delivered to X. So we have then for all X that if W of X holds true and A of X holds true, then this implies that our computer can be delivered to computer X.